Quantum computing, it feels like it's been just around the corner for, decades now? But here's the thing. We are on a very real, very tangible expedition into a whole new technological age. So in this explainer, we're going to lay out the actual map for this incredible journey. Okay, let's dive in.
Okay, so let's get right to it. This is the question everyone is asking. Let's cut through all the hype. When does this technology actually get out of the lab and start changing our lives, our security, and our biggest global problems? We're here to give you a clear roadmap with real timelines.
So, this is our expedition map for today. We're going to start with the big picture, the roadmap, then we'll climb through 3 really distinct phases of evolution, take a quick peek at the hardware race, and then wrap it all up with a summary of the path forward. Sound good?
All right, first up, the roadmap. And what you gotta understand is this isn't some single eureka moment. No, it's a predictable evolution, a journey we can actually track through very distinct phases, and it's starting right now.
So here it is, the whole journey at a glance. Right now, we are in the first phase, the NISQ era. Next up, we get into the logical qubit era. And the ultimate goal is the FTQC era. Seriously, think of it like climbing a mountain. We've got base camp, which is where we are now, then the really tough ascent, and finally the summit. Let's start right at the beginning, at base camp.
So, phase 1. This is where we are right now. This is the NISQ era. And yeah, it's our base camp on this quantum mountain. And look, it's super exciting. We're making real progress, but the conditions here, they're tough. They're unstable.
So what does NISQ even mean? It stands for Noisy Intermediate Scale Quantum. Intermediate scale means we've got a few hundred of these qubits, the basic bits of a quantum computer, which is honestly pretty powerful. But the real keyword here, the one that changes everything, is noisy. See, these early qubits, they're just incredibly fragile. They make mistakes, errors all the time, and that really limits what we can do with them.
So, how in the world do you even use these noisy, error-prone machines? Well, you don't use them alone. You put them on a team. We pair them up with classical supercomputers in what's called a hybrid system. They tackle very specific optimization jobs, and we're already seeing them show off what's called quantum advantage. For example, think about designing a new drug. A quantum computer could simulate how that molecule works in just a few hours. That same job, it might take our best supercomputer years. That's quantum advantage, right there.
Okay, so if we're gonna get any higher up this mountain, we need way better gear. We can't keep using this flimsy stuff. And that brings us to phase 2. This is the era where we finally figure out how to tame all that noise. This is where the real climb begins.
The game-changing piece of gear here is something called a logical qubit. And the concept here is just brilliant. Let me break it down for you. Imagine you have, say, 1,000 amateur hikers. Individually, they're not great. They get lost, they make mistakes. But what if you bundle them all together into one big team, and they're constantly checking on each other, correcting each other's mistakes? Well, suddenly you've created one flawless super hiker who never gets lost. That's a logical qubit. We're taking thousands of those noisy, physical qubits and using them as a team to create one perfect, self-correcting, error-free qubit.
And man, this chart just lays out the difference perfectly. We're going from these unstable, raw little building blocks that can only do a quick calculation before they just fall apart, to a stable, practically perfect tool that can run really complex, multi-step jobs without breaking a sweat. This right here is probably the single biggest leap we need to make to get a truly useful quantum computer.
And once you have these stable, logical qubits, suddenly a whole new world of possibilities just opens right up. And this isn't just theory anymore. We're talking about designing brand new materials from the atom up, or figuring out the chemistry to make these hyper-efficient batteries that could completely change our energy grid. This is real-world stuff.
And all of that work, all of that climbing brings us here, to the summit. This is phase 3, the era of fault-tolerant quantum computing. We call it FTQC for short. This is the final destination, the moment we finally have a truly universal, all-powerful quantum machine.
And just look at the sheer scale we're talking about here. It's mind-boggling. A real FTQC isn't going to have a few hundred or even a few thousand of those physical qubits. No, it's going to need over 1 million of them, all working together perfectly to power its stable core. That is a massive, massive engineering challenge.
So you build this 1 million qubit monster, but what can it actually do? Well, for starters, it can basically shatter the digital security that our entire modern world is built on. You see, an FTQC can run something called Shor's algorithm, which is famous for being able to crack the kind of encryption, like RSA, that protects, well, everything.
We're talking bank transactions, secure communications, all your private data. It all becomes an open book. This is a big deal. It's going to force the entire world to upgrade to new quantum-proof security.
But it's not just about breaking things. Its creative power is, honestly, it's even more breathtaking. We're talking about designing cancer drugs that are personalized, right there on the spot for your specific DNA, or simulating the chaos inside a nuclear fusion reactor to finally crack the code on limitless clean energy, or, get this, modeling our entire planet's climate with pinpoint accuracy. These are the tools that could solve some of humanity's biggest, oldest problems.
And this is where it all comes together. The ultimate fusion of two world-changing technologies. Sometime around 2040, these FTQC machines are expected to be the engine, the raw horsepower needed to bring about artificial superintelligence, ASI. This is the moment when the crazy growth curves of AI and quantum computing slam into each other and create something completely new, a whole new kind of intelligence.
Okay, so how are we actually building these things? It's a really good question, because there isn't just one way to get to the top of this mountain. It's actually a fierce global race with a bunch of different approaches all competing.
This table gives you a nice little snapshot of the race. You've got the superconducting guys like IBM and Google. They're all about raw speed. Then you've got ion traps. These are super stable and high quality. Then there's photonics, which has this incredible trump card. It can work at room temperature, which is huge. And finally, neutral atoms, which look like they could be really easy to scale up. Honestly, right now, it is anybody's race to the top.
Okay, we've covered a ton of ground on this climb. So let's zoom out one last time, pull it all together, and recap the whole journey we've just been on.
And this table really is the perfect summary. It lays out the whole evolution. You can see it so clearly. We start in the 2020s with the experimental NISQ era, which helps give a little boost to today's AI. Then we move into the late 2020s and early 30s with logical qubits, which will be powerful enough to really advance machine learning, the kind you need for artificial general intelligence, or AGI. And then finally, starting around 2040, we hit the FTQC era. That's when these machines start optimizing our whole society and become the powerhouse needed for true artificial superintelligence, ASI.
So if you take one thing away from all this, let it be this. What we're witnessing here it's just a profound shift. We're not just building a faster computer. We are literally moving from computers that solve some problems a bit better to computers that will solve problems we can't even imagine yet.
And that really brings us full circle. You see, this roadmap shows us that this isn't a question of if this is going to happen, but when. This incredible, world-changing power is coming. It's on the horizon. So the real question, the one we all have to start thinking about is, how are we going to prepare for the world it's about to create?